Good morning, everybody. So let us begin our workshop. So thank you all for joining. So I wanted to begin by expressing my admiration with the teachers who faced an incredibly challenging situation this year. So you had to balance online classes with face-to-face classes, and this was an incredible amount of work, and I'm very impressed how you were able to deal with the situation. So the university professors were a little bit luckier, so we had more stability. So we were told that we're teaching online, and that's what we did. So here today, I would like to talk to you about two things. So one about the Carleton Math Enrichment Center, what we do and what's available and what are our future plans. And the second thing, just to talk about the tools that we used for online teaching this year, both for enrichment courses and for the regular university courses. So we will talk about Carleton Math Enrichment Center, and I am the director of Carleton Math Enrichment Center. And so here you have my contact coordinates. Right? So don't worry. So this will be posted on YouTube, so by searching my name in YouTube, I'm sure you will be able to find this recording if needed, or also share it with your colleagues. All right. So this is us, right? So this is Carleton Math Enrichment Center, and so here there is a web link to our center, and so let me tell you a little bit about our history and statistics. So our first class ran in 2006, and in pre-pandemic year, so in 2019-2020, so we offered 16-year-long enrichment courses with 24 sections altogether. So most of our classes are on evenings, in the evenings, right? So, and they are run on campus at Carleton, and we have one class that runs on Saturdays. And in that year, in 2019, so our total enrollment was 650 students who attended our classes on a weekly basis, well, from September to April. And the spectrum of our classes, so they go, the youngest kids are in grade 3, and we offer the spectrum up to grade 12. So let me just show you what are the math enrichment courses that we offer. So the youngest ones, so we start with the math adventures classes, and so here we have we run this class at 2 grade levels. So there is a grade 3-4 class that where grade 3 and grade 4 are kind of combined together, and there is a separate class for grade 5 and 6. And so keep in mind that all these grades that are indicated here, so they are all tentative. So this shows just the level of mathematical ability of a student. And so, for example, I personally teach Mathling class, which is intended for grade 9 and 10 students, but I had students, bright students, as young as in grade 6 who were very successful in this class. All right, so after math adventures, so grade 6-7 level, so we offer number theory course. Then we have a very important sequence of courses, which is Geometry 1 and Fundamentals of Geometry 2. So then we have a basic algebra class, and we have also a class which branches out to other areas. So this is not just focused on mathematics, but it is focusing on applications of mathematics in finance, science, and arts. Then we have competitive math classes, which are mostly focused on training for math Olympiads. Then, so I'm teaching a modeling class for grade 9, 10s, and then we have also high school classes on trigonometry and calculus. And so let me talk in more detail about some of these classes. Oh, right. But also not just, we not only have math classes, but we branching out in more general science classes. So we have an extremely popular physics classes. So, so there is a great demand for physics. And we also have computer science courses that are taught by IT professionals, so by people who actually work in the industry, in high-tech sector in Ottawa. And so in future, so we want to introduce a physics 3 class, and then introduce a chemistry sequence, and create a course on combinatorics. Now, so what is our youngest level class? So here, so this is Math Adventures, and so this is basically the idea is we want to make mathematics fun for the students, but at the same time challenging. So here there are lots of interesting non-standard mathematics problems. And so we discuss topics like patterns, geometry, logic, and mathematical games. And so this is basically we want to develop here the interest in mathematics, and also show that mathematics can be fun and challenging at the same time. So our next class, where things become more structured and the curriculum becomes more rigorous. So it's the number theory course for grade 6, 7 students. So here we discuss divisibility, prime numbers, arithmetic of remainders, Euclidean algorithm. And so basically the idea here that this is a pre-algebra course. So in reality, so we want to start doing algebra without algebraic notation. So basically showing how one can calculate, say, something like 99 squared, effectively using algebraic tricks, right? So we apply this formula, a minus b squared is equal to a squared minus 2ab plus b squared, but we don't tell this the students, but just show how this works, that in example where 99 squared is written as 100 minus 1 whole squared. And we, towards the end of the course, we talk about cryptography a little bit. So an important sequence of courses, so this is extremely valuable to the students, is our sequence in geometry. So because this is classical Euclidean geometry done in a classical way. And I should express disappointment that, well, around the world, the trend is to do less geometry at school, because some say that that classical geometry, all these angles in modern day and age is somewhat less relevant. And so this cannot be further from truth. So because the main benefit of geometry sequence is not about angles or areas, but the main benefit of geometry done right is learning the logic. And so you need to develop logic skills if we want to train people for high-tech areas. Right? So if we want to train people who will excel in computer coding. So the best entry point for this is the classical Euclidean geometry with the emphasis on formal proofs. So this is the best way to train computer programs. And so this is the course that we offer. So this is a very serious course, and I extremely recommend it to anyone who wants to do career in something math related. So this is a very important skill to have. And so we have a course that is focusing on training for math contests. And our students achieved excellent results in various competitions, like the Canadian Open Math Challenge and American mathematical competitions. So there is an invitational Harvard MIT mathematics tournament where the team from Math Enrichment Center at Carleton did very well. And so there is Canadian Mathematical Olympiad, so which is used to select a Canadian team to be represented at the International Mathematical Olympiad. So what is our physics sequence? So in physics 1, so we do electricity, like Ohm's law and circuits, resistance, all this, batteries, currents. And the second half of physics 1 is ballistics. So this means like the motion with acceleration and so the parabolic trajectories. And in physics 2, so we revisit again the same topics of electricity and gravity, but now looking at in a more serious way. So we focus on forces, fields, and conservation laws, like energy conservation law, momentum conservation law, and for physics 3 that we plan to introduce at some point in the future. So we want to do electromagnetism, do an introduction to quantum mechanics. And so we want to leverage the Carleton advantage. So Carleton University has a very strong group in particle physics. So Carleton professors work at CERN, at Large Hadron Collider. And so we invite graduate students from the particle physics group to teach these courses, and so they can do a very good job of teaching elementary particles to high school students. So I'm looking forward to creating such a course. And for high school math courses, so we have Algebra and Trigonometry. So this is a course where we invest serious time, like thoroughly looking at trigonometry. So here we will do proofs by induction, Newton's binomial formula, then Moivre's formula for trig functions, and also spend good time proving trigonometric identity. So this is just a rigorous and very challenging course. And so finally, so we have Foundations of Calculus course for grade 11, 12 students. And I should say that this course is very different from a high school calculus course. So I would say that in a high school calculus course, the analogy is that students learn how to drive a car, whereas what we try to teach is what's under the hood. So what makes this engine run. And again, so here the focus on proving things, and so students learn epsilon delta technique, which is very challenging for them. Let's proceed. So this year we of course had to switch online, and so because of this. So we had to reduce the number of courses that we offer. So we decided that we will not be able to handle large online classes with very young students because of well, possible technical okay, thank you, Martin. Right, so technical issues and also like attention span issues. So, and another consideration for us is that some of our courses are taught by Carleton graduate students, and it was unfair to ask them to teach online courses because this is a huge investment of time and effort, and so we only so this year, so our team was kind of was a team of professors and professionals. So we didn't have any graduate instructors this year. And so this is the list of courses that we offered, and so this was very successful. So still we had 380 students who signed up for our courses, and so this year went really well. Now, so let me talk, so give you kind of a better feel for the course that I taught myself this year. So I taught problem solving in algebra course, so for students in grade 7, 8, and so the enrollment in this course was the initial enrollment was 111 students, and so 2 weeks ago we had the final exam, and the final exam was written by 82 students, and I think this was kind of a very good result, so very good retention rate. So the course was structured in the following way. So it was operating on a weekly cycle. So every week, students would have a pre-recorded lecture posted on YouTube on a certain topic. And so topics will change week from week. And so students will be given a list of 10 challenging problems that's related to the topic of a lecture. And so this will happen on Wednesday. So on Wednesdays, we will post a new lecture and a set of problems. And then students will start working on these problems. And on the weekend, students will have to book an individual 15-minute Zoom interview with a TA, where students will present what they have done so far and ask questions, see if there are any difficulties in solving problems. So they will get tips from TA, or TA may look at this preliminary draft of students' work and just comment that, well, so this is, for example, not perfect, and this should be done slightly differently. And then by the following Wednesday, so after meeting with the TA, students will revise their paper and submit their paper by the following Wednesday. And then this paper will be marked by TAs and returned to the student. And I think so this was a very good format. So students had the opportunity to talk to TAs, and I think well, I've heard the very positive comments from the parents. Now, so let me show you a piece from the lecture, so from one of the lectures. So I will share you the screen. So just 3 minutes of this recorded lecture, right? So the topic of the lecture is decimal expansions. So we know that rational numbers are characterized by the property that the decimal expansions are periodic. And we want to investigate how the period of the decimal expansion depends on the denominator of the fraction. So this is the subject of this conversation. So here it is.
Let us make the following table. We list small primes, 3, 7, 11, up to 23. We take the decimal expansion of fractions 1 over m, where m is that prime. And we look at the periods of these expansions. And it is instructive to start at the bottom of this table. So we see when the prime is 23, then the period of the expansion is 22. When the prime is 19, the period of the expansion is 18. When the prime is 17, the period of the expansion is 16. This suggests that the period of the expansion is the prime minus 1. However, we see that this pattern breaks down here. So if we have 13, then instead of 12, we get 6. For 11, instead of 10, we get 2. For 7, this pattern holds. 7 minus 1 is 6. So we have periodicity of 6. And for 3, instead of 2, we get 1. So what is the rule here? And what we can say is that if m is a prime, then it seems that the period of expansion of 1 over m is a divisor of m minus 1. So here we have 6 is a divisor of 12, and 2 is a divisor of 10, and 1 is a divisor of 2. Let us try to understand why such a principle might hold. To analyze this question, we'll look at long division of 1 by m. So here we take 1 and we divide it by m. And so here we're going to get a certain process. And when do we achieve periodicity? We achieve periodicity if after t steps we get a remainder of 1 in this long division process. What is our procedure of long division? At each step we pull down an extra 0. So this means that effectively we are dividing powers of 10. So first we divide 1, then we divide 10, then 100, and so on. And we say that the decimal expansion of 1 over m has a period t if the remainder of division of 10 to the power of t by m is equal to 1.
All right. Now, so basically, so this was recorded in my basement. And so I have, last summer I built something which is called a light board, right? So basically this is a large piece of acrylic plastic that is put in a frame. And so this is being recorded by a camera that's on the other side. And so if, again, you search my name on YouTube, so I have created a short video explaining how this all works. So how to build a light board. And so this costs so the cost of building this was something like around $500. So the piece of plastic was the most expensive piece there. So let me also show you what kind of problems do we give to our students. So this is one of the actual problems from one of the home assignments. So here, so I'm riding a bicycle at a constant speed along an LRT line, and I'm watching the trains go by, and I see that every 12 minutes a train overtakes me, and every 4 minutes I meet an oncoming train. And all trains move at the constant speeds and there are equal intervals between trains in both directions. And so the question is, what is the time interval between two trains? Right? And so because I don't want you to focus on the problem instead of following this workshop, so I'll just give you a spoiler, and so the answer is that the interval between two trains is 6 minutes. Right. Now, so what are possible kind of options of what I have seen from my colleagues regarding online class delivery? Well, so what I did is, so I did pre-recorded videos that I posted on YouTube, and so I decided that I don't want to create something disposable, so I wanted to create something that is kind of might have a lasting effect, and so I invested a lot of time and effort in creating these videos recorded with a live board. And so now I have more than 100 videos on YouTube. So never before I could imagine that I will have my own YouTube channel and with 100 of videos. So that was never in my plans. But now this is what happened. Then another interesting format that some of my colleagues are using is podcasts. So they would create a PDF file with a lecture, and then record an audio recording for this lecture. So this means that students may navigate through the PDF file and listen to the audio recording. So this works especially well for students who have weak internet connection, because it's much easier to download an audio file, and then just everything then is happening locally on the computer at home. And the most popular format was having live lectures that are recorded, and then the recordings are posted. And so these live lectures will be done using a computer tablet with something like OneNote software. So this is a very common format for university classes and also for math enrichment classes. Now, the main challenge for us, and I'm sure for you as well, when we teach online, is the student engagement. And I found that it is particularly difficult to get feedback from the class. So when we're teaching face-to-face, we can see whether we are connecting to the students, right? So if there is understanding in the classroom of what's going on. And when things go online, this feedback is much harder to get. And so because of this, I cannot say that I was very successful in my university teaching, even though I have invested a lot in teaching online this year. And I wish I could go back to September and do certain things in a different way. But so what we need to think about is, again, student engagement, and an important tool for university classes was organizing study groups. And so I think this is incredibly important for the students to have peers with whom they could discuss the topics. And so this idea of study groups worked better for more senior students at university, but for first-year students who lacked social connections in their class, so this unfortunately did not go as well as I have planned. Then another thing that I would like to share with you is the use of Discord. So what I've learned is that, well, we have certain entertainment platforms that very well can work for education purposes as well. So one of these platforms is Discord, which is the platform of choice for gaming community. And instead of gaming, so you can use the same platform to teach a class. And so if you have not seen Discord before, so let me show you how a Discord looks like. So this I cannot show you the actual class. So here I just created a demo course, right? So here in the screen, on the right side of the screen, so you will see the users who are present online at this moment. And then in the center here, so we could have a forum, so where we can discuss the questions that came up in the course. And so Discord may be used both in real time, but also asynchronously. So this means that a student may post a question, and then this question may be answered either by other students in this class or by the course instructor, right? And so there is even a way how one can write mathematics. So if you install a tech bot on the server, then we can use LaTeX to type mathematics. And so if you haven't seen LaTeX, so it's a really kind of widely used system by mathematicians and physicists. So basically, this is a professional system for mathematical typesetting. Unfortunately, so the raw LaTeX looks like abracadabra a little bit, right? So one has to learn a little bit of gibberish before one can create nice things. But once this initial barrier is crossed, then things become much better. But so in addition to this forum, here one can create space for study groups. So for example, so here on the left panel, so there are channels for study groups. So there are text channels and there are also voice channels. And so for example, a group of students may go, say, during the class or whenever they want, they can join these channels and have a discussion between themselves. So this is like breakout rooms, but again, this is something that is always there. So you don't have to, so this is all run on some server, and so you don't have to be involved in maintaining this platform. So I find that so Discord can be very useful for well, communications and for running the classes, and also it's embraced by students because this platform is very familiar to the students. So once I open up access to a Discord server for my class, immediately within 1 minute, I will have 10 students who would just land on the server. And so because they have Discord running all the time. And well, something that's less relevant for high schools, but nonetheless, let me show you. So so the question was how to do collaborative mathematics. And so there is, of course, an option of whiteboards, but for me, I found that unless you have a tablet, then using a whiteboard is very painful. So I cannot write anything sensible with a mouse on the whiteboard, and we can't expect that every student has a tablet. So because of this, so what I used in my classes, and again, this is yeah, there is also, right, so Sean says that there is Equator. I'm not kind of familiar with Equator. I've heard about it, but I never used it. So instead, what we used for our classes is overleaf, which is overleaf is the online LaTeX system where one can write LaTeX online, and also it's collaborative. So this means that several people may be working on the same document, right? So this file is a file that I prepared for one of the tutorials for a graduate course on Galois theory, right? So this is how the finished product looks like. But here you can switch between two modes, right? So there is this PDF mode, and there is also raw LaTeX mode, right? And so if we switch to raw LaTeX, so then this is how the same thing looks. This is how you create these documents, right? So this is what you type. And so, for example, if we want to do, say, quadratic formula, so then this is how we type mathematics. Right. Okay. So and now we can just recompile PDF. Right. And so now we see that so here what we have just typed, so appeared in a nice mathematical typeset. And so with Overleaf, so basically it's a website, overleaf.com, and with this website, so you can have several people who can work on the same LaTeX document at the same time in parallel. And, so here, students working in a study group, so they can create one joint common document. And so this is what we used. Right. Okay. So let us return to the presentation. Right. So one more thing that I wanted to show you is what I used for office hours. So in office hours, so I instead of buying a tablet, right? So I don't own a tablet. So what I decided to do is I wanted to do a cheaper solution, and so instead for office hours, I'm using this. So let me see. I can adjust this. So I'm using a phone holder, right? So this piece here. So this is a phone holder, right? And so now what I'm going to do is I'm going to connect to this Zoom session from my phone. So there is something which is called YB dock camera. So here I put this my phone in this phone holder here, right? And so if you look at this another Zoom window, which is called Yuli dock camera, something like this, right? So then, so here, so if you put your mouse to this dock camera window, then you will see this blue button with 3 dots. And there, so if you click on these 3 dots, you can pin this window so it becomes large, right? And so if you pin this window, so then you will see this this piece of paper, right? And now I can write on this paper. And so now in real time, so I can write mathematics and talk to my students at the same time. And so this phone holder, right? So this is called gooseneck phone holder. So this, so I paid $20 on Amazon, and it was kind of a very useful investment. And so this is what I used for the office hours. So basically, so these are the tools that we used, and the hope is that in the future we will retain some of these tools even when we teach classes face to face. And so definitely I will be using Discord server for communicating with class beyond this. And one of the plans for the Math Enrichment Center is, so we want to bring some of our courses online, and we want to serve northern and indigenous communities in Canada. And so we will leverage this online experience so that we can run online classes for remote communities. So that's the plan. And so let me speak a little bit about our future plans and about the equity, diversity, and inclusion. So since this is the theme of this PD Day today. So first of all, well, I should say that Carleton Math Enrichment Center is a non-profit organization. And so we run our classes not for profit. And at the beginning, when we started our classes, so we had a kind of serious discussion whether we should offer our classes for free or we should charge a reasonable fee for the classes. And so what we do is, one of our classes is free, but most classes, so there is a registration fee for the class. And even though ideologically I felt that math enrichment should be free, but nonetheless, like pragmatically, I see that fee-based system is more effective because so we use Math Enrichment Center also as a training opportunity for future educators. So we have a good number of best graduate students and best undergraduate students who are involved with the Math Enrichment Center. And then for a graduate student, if they have to decide whether they should do what they love to do and teach kids mathematics, or they should get a part-time job so that they're able to pay rent. So this, for many, becomes a difficult decision. And, oh, sorry, I should maybe move this camera here. Right, so, and if we charge a fee for the course, then basically we make this decision easier. So students may teach math enrichment and also get paid for it. And so this is a win-win situation. But we certainly understand that for some families, so this may cause hardship. And because of this, from the very start, we were offering fee waivers. So any family who would have difficulties paying the tuition fee, so we are happy to offer fee waivers. And so basically every year we have no cap on this. So we will offer fee waivers to everybody who is in need. And so typically, so we would offer between 20 to 30 fee waivers every year. And so this is kind of need-based, so there is no cap here. And so our plans for the future is we would like to work with the indigenous women organizations and with Black women organizations to promote what we are doing. And so in case of Black kids, so we would like to see more Black kids in our classes, and we would like to kind of make a promotional effort in this direction. And so for indigenous communities, so we already were in the talks with some people in Nunavut to organize online classes for schools in Nunavut. And this is not necessarily, so we want to start with younger kids so that we can bring up students. We understand that for some, say, indigenous communities, so maybe the level, the starting level may not be the same. And so we will definitely tailor our classes to the needs of the kids there. And so we hope that once the pandemic is over, so we can go back, resume these discussions and use what we learned in online teaching this year, and so deploy these tools to serve kids who are outside Ottawa. And so finally, so let me ask you something, right? So how can teachers help here? So, and I think, so what would be really nice if you could recommend the students' enrichment on student report cards. So I'm sure that you have seen kids in class who could have done better in your math course or science course, but they kind of felt bored by the standard set of problems, right? So there are students who do not do that well because they, well, who could have done better in class. And so we want these students in our classes. And so trust me, so we can challenge students. So our math enrichment courses are very challenging, and I have not heard any comments that they are not challenging enough. I do not suggest that you recommend Carleton Math Enrichment Center specifically on the report card, so this may not be appropriate, but at least put this seed of an idea that math or science enrichment is something that students can do, because so culturally in Canada, so families, all families know that hockey is a possibility that they might consider. Right? So any Canadian kid could, well, would think whether they should do hockey or not. And many do, and I'm happy for that. But unfortunately, historically, so many families are not aware of the fact that there are opportunities for math and science enrichment, and this is something that is readily available and here, so that's accessible here in Ottawa. And so many parents simply just don't know about the opportunities that are present. All right, so the question, what would we like to see being covered with more detail? So probably this is about kind of Ontario curriculum. So I would say that at intermediate schools, this is definitely geometry. So it's really a shame that 2000 years ago, at the time of Pythagoras, geometry was taught in schools better than it is taught today. So the state of geometry in the Ontario curriculum is pretty sad, and the trend is to have less and less geometry, and I cannot agree with this. So we need more geometry if we want to go to high-tech based economy. And at high school level, certainly trigonometry. I know that so with trigonometry and with many other subjects in mathematics, so it's a patchwork. So I would say that the Ontario curriculum is not detailed enough. So it says what topics need to be discussed, but it does not give a guidance in which detail, what is the granularity level for discussing these topics. And trigonometry is one of the examples. Like on the books, it's there, and I know that some teachers do a very good job of teaching trigonometry in high school. But I also know that in many schools, trigonometry is done in a very cursory way. So I've heard students, university students, telling me that their teacher would just have one class where all three formulas would be put on the projector, and they would look at this computer screen for 10 minutes, and this was it, right? And trigonometry is extremely important for students who go into engineering programs. So engineering needs a lot of trigonometry, because if you go into signal processing, then of course signal processing is all done with trig functions, right? So you need to know Fourier transforms, and Fourier transforms are based on trigonometry. And so currently in high school, the again, trigonometry is a soft spot. And more fundamentally, but again, so this is something that is hard to ask, is proofs, right? So right now in Ontario curriculum, there is very little emphasis on mathematical logic and proofs. And this is kind of too bad, because so this rigorous thinking where you need to analyze and crystallize the problem. So this is extremely valuable, again, for computer programming. And we're not teaching this skill well enough. And one of the issues is, again, streaming. So for some reason, streaming is a bad word in our education system. And I do not agree with that. So I think streaming, so if we are to be pragmatic, right, and so if we need to train our elite for tech sector, which will be more and more foundational in Canadian economy, so we need to seek talented people and put extra efforts in training talented people. So the people with talents in mathematics may come from all walks of life, and we need to find them, nurture them, and work with them so that they become the pillars of our economy. So if there are no further questions, so thank you everybody for participating.